Hello there and welcome to this video that's going to go through a whole bunch of questions looking at solving trig equations in Radians mode. So this is a video aimed at the start of the trigonometry section in the second year of A-level maths, and it's going to go through questions that are doable from the first year knowledge of solving trigonometric equations. You'll need to know sine squared plus cos squared equals 1, sine divided by cos is tan. But this time all of our answers are going to be in Radians mode. So before we start this video, just double make sure that your calculator is in Radians mode. You should be able to see a little R on the very top row of your calculator screen. Just make sure you're in Radians mode before we start this video. So it's going to be question after question. Pause the video, I'll go through the answer, move on to the next one, pause video, have a go at the next one, and I'll go through the answer each time. So let's move on to the first one then. Make sure you give your answers in between 0 to 2 pi. Remember, 2 pi is about 300 is exactly 360 degrees when you convert it over. So yeah, solve this equation on the left hand side here. Cos x equals a half. Okay, so the first thing we need to do here is going to be cos inverse. So grab your calculator, cos inverse of 1/2. And cos inverse of a half is pi by 3. So sometimes it's exactly a fraction relating to pi. Sometimes it isn't. So sometimes it is, sometimes it isn't. If you're lucky it is, if you're unlucky it isn't. Now we need to get the second solution in this range here. So remember that the cos graph starts at 0, starts at 1, sorry, and will go like this. It will finish and repeat every 2 pi radians, and the halfway points will be pi radians. So for 1/2, we're going to get an answer of pi by 3. We're also going to get a second answer over here, which will be, well, if we start from the top and work downwards, then that's going to be a distance of pi by 3 on the x-axis. So if we start from the top and work backwards down from here, then we have to take away pi by 3 from 2 pi. So it's going to be 2 pi minus pi by 3, which is 5 pi by 3. So there we are. Our final answers in this range are pi by 3 and 5 pi by 3. So there we are. So remember, for cos, this is how the graph looks, and you always start from the top and work your way down to your solution. Top at 2 pi, backwards down to your solution. So you have to take away pi by 3. Let's move on to the next one. So pause video, give this one a go. Let's now go through it. So the first thing we need to do here is x equals tan inverse of minus 1 over root 3. So grab your calculator, tan inverse fraction button minus 1 over root 3. And the answer to that is minus pi by 6. Now that answer is not going to be one of our final answers because it's not in between the range or the domain of 0 to 2 pi. So what we'll have to do then is draw out our tan graph. Several waves that repeat themselves every 360 degrees, and the middle goes through 0, 0. So at the moment we've got pi by 2 here, 3 pi by 2, and this will be here intersecting at pi and 2 pi, repeats itself every pi radians. So what we've got so far is we've got an intersection down here of minus 1 over root 3, and that's given us this solution back here, which is minus pi by 6. So to get the next solution with the tan graph, you just add on pi radians each time to get to the next solution onwards. So the next solution is going to be minus pi by 6 add pi, which will be 5 pi by 6. And then the next solution as well will be take that solution we've just found and add another pi onto it. And we're going to get 11 pi by 6. So there we are. These two answers here, x equals 5 pi by 6 and x equals 11 pi by 6, are the final answers in this question. Okay, let's move on to the next one. So it's sine of x equals minus 1 over root 2. So the first thing we always do with these types of questions is we do sine inverse. This is a pretty straightforward question, relatively speaking. And in this question here, we're going to get inverse sine fraction button minus 1 over root 2. And we get minus pi by 4. Now that is not going to be a final answer in our given domain because our answers have to be in between 0 to 2 pi. So what we'll do next is we'll get out the sine graph. Starts at 0, then goes through its rotation, goes through its wave, sorry. It comes back at 0 every pi radians. And what we've found so far is that for minus 1 over root 2, we get a solution back here, which is at minus pi by 4. So the little distance from the bottom of the graph backwards here is a distance backwards of pi by 4. So what we'll do then is if we want to work out the next solutions, then we'll start from pi and we'll move by this little distance here upwards by pi by 4. So the next solution here is going to be pi plus that distance of pi by 4 along the graph to get to our next solution. So that would be 5 pi by 4. And then from 2 pi coming backwards by that little distance, the next solution therefore is going to be 2 pi minus pi by 4, which will give us 7 pi by 4. So there we are. Those are our two solutions for this question. X equals 5 pi by 4 and x equals 7 pi by 4. Okay, so moving on to the next question, and what we've got here is something ever so slightly different. It's tan of x plus pi by 6. So you remember what to do with these questions. These were as well in the first year of A-level maths. You take each of the 3 different sections and add pi by 6 so that your angle is exactly the same as the angle that's inside tan. So the middle bit we'll do first. That will turn into x plus pi by 6. And now that's exactly the same as what we have inside tan, which is the reason for doing this. Now we'll just make sure we've done everything the same on all 3 components of this inequality. This will turn into 13 pi by 6. And now we can proceed with this question because we've got a variable of x plus pi by 6 the same as what we have inside our tan function. Okay, so what I'm now going to do, I'm not going to do this every time, I'm just going to do it this once just to make things a bit easier for ourselves, is I'm now going to replace x plus pi by 6 with the letter y. So I'll bring x back in later on, don't worry, we haven't just completely forgotten about x, but I'm just going to be replacing x plus pi by 6 with the letter y. So now my question is tan of y equals root 3. So now I'll do y equals tan inverse of root 3, which is going to be tan inverse root 3, and that's pi by 3. So now I need to make sure to find the second solution to y, I need to make sure I've drawn the tan graph at least between pi by 6 to 13 pi by 6. So I'll draw my tan graph. And usually I draw a few of these little squiggles. These squiggles repeat themselves every pi radians, starting at 0. So it will go through pi by 2, 3 pi by 2, so the asymptotes here, 5 pi by 2, and that will at least cover the range of pi by 6 to 13 pi by 6. It will intersect at pi and at 2 pi. So our first solution was finding the solution to root 3, and that had an answer of pi by 3. Now to get the next solution on from here, you add pi radians. That's what you do to the tan graph. So y is equal to pi by 3 plus pi, which is 4 pi by 3. And maybe there might be a third solution, and we'll add another pi just to see if this next solution would be inside this range here. So the next one will start at 4 pi by 3 and add on an extra pi for moving on to the next solution on the graph, and that's going to be 7 pi by 3. Now if you work out the fractional value of 7 pi by 3 and 13 pi by 6, this 7 pi by 3 is actually outside of this range for y, so we're not going to include it as one of our final answers. I did it just to check, because I didn't quite know whether it would be inside or outside. I did it, checked it, and realised that it was outside the range. So we've got two solutions here. We've got y equals pi by 3 and y equals 4 pi by 3. But now we need our answer for x's. So if y is equal to pi by 3, then x plus pi by 6 is equal to pi by 3. Let's now work out what x is. So we'll take away pi by 6 from both sides, and we'll be left with x equals pi by 6. Let's also do exactly the same for this solution down here. X plus pi by 6 equals 4 pi by 3. And now let's work out what x is by taking away pi by 6 from both sides. And x here, I'm just going to use my calculator for this. 4 pi by 3 minus pi by 6. That gives us 7 over 6, so 7 pi by 6. So those are the two answers here for x. So what you might find helpful is if you've got anything that's happening inside your tan or sine or cos, like this thing here, x plus pi by 6, then always first, sort out your domain. So make sure that your angle inside the inequality is the same as the angle that's inside sine, cos or tan. And make sure you've got the same function being applied to all three parts of your inequality here, so that everything stays level. Then replace that transformed x thing with a new letter. We'll call that letter y. Work out what y needs to be, and then finally just work out what x needs to be by undoing that transformation, which was add pi by 6, by taking away pi by 6 to work out what x is. X should always be your final answer here. Alright, let's move on to the next one. So we'll do something very similar here, and the first thing to start off with is x minus pi by 4. So the first thing I'll do here is I'll take x and take away pi by 4 so that I have the same thing inside my angle, so x minus pi by 4. The next thing I need to do is make sure that I've done the same operation to all three components of the inequality. So I'll take away pi by 4 from all three components. So I'll have minus 5 pi by 4. And here I'll have 3 pi by 4. So this is going to be my new range for my answers. And what I think I'll do, just to make my life easier later on, is I'm going to replace x minus pi by 4 with the new letter y. So I'm now going to work out what y is, and then I'll work out what x is right at the end. So I've now got an equation which says sine of y equals 1/2. So the first thing I'll do is inverse that sine, and I'll get x, so y equals pi by 6. So now I need to work out what the other solutions are, and this time it's in between minus pi to pi, or actually minus 5 pi by 4 to 3 pi by 4. So I'm going to need both sides of the sine graph. So I know it goes this way here, and also backwards like that. This here would be at pi, this here would be at 2 pi, this back here would be at minus pi, and this bit back here would be at minus 2 pi. So I've got my solution for 1/2. The first solution here was pi by 6. And let's just see if I've got another solution up here, or potentially back here as well. Minus back here, or maybe back here. So let's check all of those 4 solutions. So what I'm going to first do is just create a little adjustment on the graph here, or a little distance here, which is the distance of pi by 6 on the x-axis. And I'm going to come backwards by that little distance of pi by 6 from pi to get to my next solution. So y is going to equal pi minus pi by 6, which will be 5 pi by 6. Now, would that be a potential answer for y? Is what's bigger, 5 pi by 6 or 3 pi by 4? I think 5 pi by 6 is actually too big, so this is outside the range of our final answers. So no, we're not going to include that as a final answer because it's not a potential value for y. What about looking back here then, looking back at this solution all the way back here? So in this case, the little distance will be from minus pi, and it will be going backwards by pi by 6, so minus pi by 6, which would be minus 7 pi by 6. And would that be inside this range here? Yes, it would be inside this range here, because this is a bigger value than minus 5 pi by 4. It's inside this range here. And actually this solution down here looks like it's going to be way too small, so we won't even bother finding this one. And generally in between a range of 2 pi radians, you're only going to get 2 solutions. So we have our solutions then. Well, our solutions for y anyway. First one being pi by 6, and the second one being minus 7 pi by 6. Now if y is equal to pi by 6, then it's the same as saying x minus pi by 4 is equal to pi by 6, because that's what y is. Y we just replaced pi, so x minus pi by 4. So the next thing we need to do is add pi by 4 to the other side to work out what x is. So I'll do that on my calculator. Pi divided by 6, add pi divided by 4, and I get 5 pi by 12. And on this one down here, y is equal to minus 7 pi by 6, so that's the same as saying x minus pi by 4 is equal to minus 7 pi by 6. So add pi by 4 onto both sides of this, so I'll do this very carefully on my calculator. Minus 7 pi by 6, and then add pi by 4, and I get minus 11 over 12, x equals minus 11 pi over 12. So these two answers here are the final answers for x. So it's really important you work out what y could potentially be first, and then the final thing you do is just undo the minus pi by 4 by adding pi by 4 to get your final answers for x. Okay, so moving on to the next question here, we've got a very similar one. Cos of x plus pi by 3 equals minus root 3 over 2 from minus pi to pi. So the first thing I'm going to do in this question is take the inequality or the range of values for x and change it so that it's the same as the angle that's inside cos. So it's going to be x plus pi by 3. And then I'm doing exactly the same thing to the other sides of the inequality. So it's going to be minus 2 pi by 3. And on this side it would be 4 pi by 3. So I'm looking for values of the angle in between minus 2 pi by 3 to 4 pi by 3. Now I'm going to try and do this question without introducing the letter y in there. I'm going to show you how to do it this alternative way. So the first thing I'm going to do is inverse the cos on both sides of the equation. So I'll have the angle, which is x plus pi by 3, equals cos inverse of minus root 3 over 2. So do that on the calculator in the radians mode. Minus root 3 over 2, and that equals 5 pi by 6. So now I've got x plus pi by 3 equals 5 pi by 6. Now don't work out x here at the moment, because x isn't the angle we're going to be cosing, it's going to be the angle x plus pi by 3. So before I take away pi by 3 onto the side, I need to find out what other angles will cos to make minus root 3 over 2. So the next thing I need to do is draw the graph to find the second solutions. So remember that the cos graph looks roughly like this one here. And I'll have intersections at pi by 2, minimum points at pi, intersection at 3 pi by 2, and at 2 pi. And I get exactly the same stuff on the other side, just all negative. And I need to make sure I've drawn my graph at least covering this region here. If I've drawn more of the graph than this region here, then that's absolutely fine. So the first solution I found was minus root 3 over 2, and that gave me a solution of 5 pi by 6. Now I'm looking for second solutions. There might be one up here, or there might potentially be one back here. So I've got one solution here. Let's check this solution over here. Now what you should be able to spot is that the cos graph is perfectly symmetric around the y-axis. So this solution over here is minus 5 pi by 6. But that would be outside of this range here. Or would it be inside, outside? I think it would be outside of this range here. Yeah, it would be outside of the range. So this is not one of our next solutions. We'll have to look further up the graph for our next solution. Now notice that, how do we work that out? Well, we've gone down from the top by 5 pi by 6. So we'll have to come back from the top by 5 pi by 6 to get the next solution. So the next solution to our angle is x plus pi by 3, will be equal to 2 pi minus 5 pi by 6. And that will give us 7 pi by 6. And would that be inside the range of this angle from here to here? Yeah, it would be inside of this range of angle from here to here. So the angle is potentially, let's do the work over here for this. The angle of x plus pi by 3 will either equal 5 pi by 6, or the angle which is x plus pi by 3 will equal 7 pi by 6. And the last thing we need to do on both of these equations is take away the pi by 3 onto the other side, so that we can then work out what x is. And on the first one here, that will be 3 pi by 6, which is pi by 2. And on this side here, it's going to be 5 pi by 6 as the final two answers. So there we are. Those are our two answers to this question. We worked out what the angle was first by inversing the cos, work out the second value that the angle could be, and then finally work out what x is by removing the pi by 3 from the angle. Alright, then moving on to the next question. So instead of adding something inside the angle now, we're doubling the angle. So we will times the angle by 2. So now we have the same part in the inequality as we do inside the cos. So we're working with the same angle now. And what we need to do now is do exactly the same thing on the left and the right hand side of the inequality. So we're now working with an angle in between minus 2 pi up to pi. And our angle that we're working with is 2x. So the first thing we need to do here is do inverse cos of minus 1 over root 2. And inverse cos minus 1 over root 2 will give us 3 pi by 4. So the next thing we need to do is, we don't half it yet, our angle is still 2x, we need to work out what other angles will give you minus 1 over root 2 when you do the cos of it. So we're looking for the next angles next. So we need to draw the graph in between minus 2 pi and 2 pi, because that's what the angle could potentially be. So we are first drawing out this graph up to 2 pi and down to minus 2 pi. When we did minus 1 over root 2, we got a solution of 3 pi by 4. So let's now look for other solutions by looking horizontally to see what other output would give us minus 1 over root 2. This is our first solution over here, and the easiest one to go to would be this one over here, because it's symmetrically the other side of the y-axis. So that's our second solution. Another solution, if we start from the top of the cos graph and go down by 3 pi by 4, then that would get us to this first solution here, and we can do symmetrically the same on the other side to get to this solution down here. So the next solution is going to be for 2x, 2 pi minus 3 pi by 4. And that will give us 5 pi by 4. So 5 pi by 4 will be the next solution. And symmetrically, it would be the same for this one over here, minus 5 pi by 4. So we have 4 potential answers in this question, and all of them are acceptable because they're all in between minus 2 pi to 2 pi. If you think about it, we've got a range here of 4 pi, and you'd expect 4 answers in that 4 pi range. So we've got 2x, the angle could equal 3 pi by 4. The angle 2x could also equal 5 pi by 4. The angle of 2x could equal minus 3 pi by 4. Or the angle 2x could equal minus 5 pi by 4. So first we've worked out what this angle could equal. Now let's work out what x is equal to on all of them. So we're going to half the 2x, and that will half all of the angles, so that will now be 3 pi by 8, 5 pi by 8, minus 3 pi by 8, and minus 5 pi by 8. And there we are, that's the answer to this equation here. 4 solutions to this one here. So just a reminder, first thing we do is we look for all the potential angles for 2x, and then the last thing we do is we halve all of those angles to make sure we find what x is. Okay, so let's move on to the next one, and we've got a 3x now, so that'll be the first thing we change in our angle, so that we've now got the same angle as we've got inside the tan. So that's now going to mean that we're looking for answers in between minus 3 pi up to 3 pi. So the first thing we'll do then is we will find what the angle, the first answer for what the angle will equal, and that will be tan inverse of 1 over root 3, and that will give us pi by 6. And now we've got to work out what other answers 3x could equal to give us a tan of 1 over root 3. So the next thing we'll do is we'll draw our graph. So remember, our graph is going to go through 0, and then it will just repeat itself every pi radian. So that'll be up to pi, 2 pi, and remember this needs to go up to 3 pi. So I'll draw another extra half a curve, and that will get me up to 3 pi. And then working on the same thing going backwards, let's just make sure we try and fit this in. Minus pi here, 2 pi, minus 2 pi here, and then the next bit will be the top bit here, which will be 3 pi. So our output here was positive minus 1 over root 3, and that will give us this solution here, which was pi by 3. Another solution up here, and another solution up here. Then we'll go backwards for solutions here, here, and here. And remember, tan is quite an easy one to work with because for tan, you just either add or subtract pi to get from one solution to the next solution. So when you go back, you just take away pi from your previous solution. So we're going to get 6 answers here. First one is going to be pi by 6. Let's add pi to get to the next one, which will be 7 pi by 6. Let's add another pi to get us to the next solution, which will be 13 pi by 6. Let's go backwards now from pi by 6 by pi, that will be minus 5 pi by 6. Take away another pi and we're at minus 11 pi by 6. And, whoops, double negative there. And take away another pi and we're down to minus 17 pi by 6. So these are all the angles that we could put into tan to give us 1 over root 3. And the final thing we need to do now is divide all of these by 3 to actually work out what x is. So that's going to be pi by 18. Well, it's all of these answers, but over 18 instead of being over 6. And you can check that we've done the right thing here and that we've not got any extra solutions, because minus 17 pi over 18 is just a little bit less than pi, actually a little bit inside the range of minus pi to pi, so a little bit more than minus pi. So we've got all of our answers inside that original domain of minus pi to pi. Okay, so moving on to the next question, it's cos 2x equals 0.315. First thing I'll do is I'll make sure that my angle in the range is the same as the angle inside the cos. So it'll be 2x inside here. I've doubled the middle, I'll double the right hand side, and I'll also double the left hand side. So the angles that I'm looking for in my final answer are in between 0 to 4 pi. The next thing I need to do is then do an inverse cos of 0.315. And I'm going to show you how to do this on the calculator. This is the only question I'll do on the calculator, but I'll show you how I would use it exactly. So the answer to this bit here is 1.25. I'm not going to write any more decimals than that, but I'm going to continually use that as the answer value going ahead. Now I'm going to have to adjust all my calculations to continue to use this as my answer value. So instead of just continually using the answer button over and over again, because I'll have to reload it with this every time I want to use it as the answer button, I'm going to store it as letter A in my calculator. How am I going to do that? Well, I'm going to hit the STO button, this button here. It says STO on it. And then after that, I'm going to press the button with the letter A above it. I don't need to press alpha for this step. I'm just going to press this button here and then this button here. And that will store it as option A. So it's going to be stored now as variable A in my calculator. It's going to be a helpful value that I'm going to need to use over and over again in working out the second, third and fourth solutions. So let's carry this on. I now need to draw the graph in between 0 to 4 pi, and the cos graph will look something like that. So it would be pi here, 2 pi here, 3 pi here, 4 pi here. And the first solution, my output was 0.315. And my output here was 1.25, and that kind of makes sense because pi by 2, if pi is 3.14, then pi by 2 is 1.57, which is a little bit less, which 1.25 is a little bit less than. I'll carry on doing my dotted line across to get second solution, third solution, and fourth solution. So the distance on the graph from the top, from the peak of the graph, has been 1.25 from 0. And now I'm going to start at the peak above 2 pi and come down to work out my next solution. So I'm going to be subtracting 1.25 here. I'm going to start at my third solution, will be add 1.25 from 2 pi, and then from 4 pi I'm going to come backwards by 1.25. Or not 1.25 exactly, but 1.25033963. So my next solution for 2x, the angle, will be 2 pi minus 1.25, or not 1.25 exactly, but 1.25033963. So what I'll do to work this out exactly is I will press 2 pi minus, and this is where I have to use the alpha button, alpha, and then the option for a. So it's 2 shift times 10 to the power of x, so times 2 pi minus alpha, and then the negative number button, which will make you have an a appear. And this will give it to you in exact form. Not in exact form, but as a very accurate decimal. The next solution will be 2 pi plus 1.25. Now, not 1.25 exactly, but the original big long decimal. So I'll do 2 pi plus a, and a was stored as that 1.25 ... value. So 7.53 will be that solution. And the final solution will be 4 pi minus 1.25 ... So I'll do that as my final calculation. 11.32 will be this rounded to 2 decimal places. The final thing I need to do is now half all of these values. Now the most accurate way of doing this would be to go back to solution A. So for the half of this 2x solution up here, 1.25, it'd be better to do a divided by 2. And to 3 significant figures, that's 0.625. Then I need to half 5.03, and the most accurate way of doing that would be to do 2 pi minus a, all divided by 2, which would be 2.52 to 3 significant figures. Moving on to the next one, 2 pi plus a divided by 2, that would be 3.77 to 3 significant figures. And the final solution, 4 pi minus a divided by 2, will be 5.66. So these here are the most accurate answers that we could hope for, because we've always used the exact answer to cos inverse 0.315. So these are correct to 3 significant figures. Now I'm not going to show using this in the future questions that I'm going to work on, but I'm always going to be doing that in my calculator. Okay, so moving on to the next question. The first thing I need to do here is half the angle x, because I always want my my solution here, my range of angles for x, to have the same angle that it does inside the trigonometric function. So half the x first. The next thing to do would be to write half x equals sine inverse 0.09. That's going to give me an answer of sine inverse 0.09. 0.09. 0.90. Okay, the next thing to do will be to check for other answers. So I'll have to do it from minus pi, so pi by 2 to minus pi by 2. And we can see here there are no other solutions. So the only solution to this question is x equals half x equals 0.090. So the answer to what x is will be double this. So answer value times 2 will be 0.180. And there we are, that's the answer to that question. Let's move on to the next one. So in this question, what I'm going to do is I'm going to have to rearrange this before starting to work out what x is. So the first thing I'll do is I'll take away 1 onto the other side. Next thing I'll do is I'll divide both sides by 3. And now I can start to work with the cos inverse. So cos inverse, and make sure you use the actual fraction value of minus a third here. Don't type in minus 0.3 here, because you won't get as accurate answer. Cos inverse, fraction button minus 1 over 3. And that would give me 1.911. There would be a 6, but I'm now going to store that as the value for A in my calculator. The next thing I need to do is check for other solutions in between 0 to 2 pi. I didn't need to do anything with the angle here because the angle was just x. So cos graph will look like this. So my solution here was minus 1/3. So I'll get my solution appearing here, 1.911. 1.911, sorry, that's not 1.911, is it? We need to actually work this one out. So it's a distance of 1.911 down from the peak to the solution. So I'll have to come exactly the same distance backwards from a peak of 2 pi. So the second solution here is going to be 2 pi minus A, or answer value. So 2 pi minus my value A, which is 4.37. So my answers here to 3 significant figures were 1.91 and 4.37. And there we are, that's the answer to this question. Okay, so moving on to the next question, we have 5 plus 3 tan equals 0. First thing I need to do then is to rearrange this to get tan on its own. So the first thing I'll do is take away 5 from both sides. So I'll get minus 5 on the right hand side. Then I'll divide by 3, so I'll get tan x equals minus 5/3. So I've got rid of everything surrounding tan. Now I can start solving this like a trigonometric equation. Don't need to do anything to x because my angle inside is just x here, so I don't need to fiddle around with this range on the right hand side. So first solution will be x equals tan inverse of minus 5/3. So do that on your calculator and you get minus 1.03 to 3 significant figures. Now obviously this final answer here will be outside of my final answers because it's not in the range from 0 to 2 pi. So when I draw the graph from 0 to 2 pi, it won't appear on here, so I'll have to extend it backwards from 0 to get my actual first solution, which was an answer of minus 1.03. The way I find the next solutions is I just add pi each time. So add pi, because the tan graph repeats itself every pi radians, I'll just add pi onto my answers. So take this answer and then just add pi. Whoops, I've times by pi there, so I need to go back. Add pi 2.11 and then add another pi again to get onto the next solution. So add pi again and I get 5.25. And there we are. These are the two answers for this equation here. Let's move on to the next one. So in this case, we've got a little bit more to work with here. First thing I need to do is take away 1 onto the other side. Then I'll divide by 6. And then the next thing I need to do is sort out the angle because it's a 2x. So it's going to be 2x. So I've doubled the x. So I need to double both sides here from minus 2 pi to 2 pi now. So my angle here is going to be in between minus 2 pi to pi. The next thing I'll do is I'll do inverse sine of this. So sine inverse minus 1 over 6. And let's do this on the calculator. Sine inverse minus fraction button 1 over 6. And I get an answer of minus 1.67 That's to three significant figures. What I'm going to do now is I'm going to store that as the value for a on my calculator so I can then use it later on. I need to now draw my graph in between minus 2 pi to 2 pi. So that's what my sine graph will look like. That would be 0, that would be pi, that would be 2 pi. This would be minus pi, and this would be minus 2 pi. So my answer here was minus 1/6, that was the output. So my first answer here of minus 0.167 goes here. So I now need to find the next solutions. And the way that I'm going to do that is I'm going to highlight it in blue here just to make it super obvious, is that this little distance from here to here is a distance of 0.167. So if I was to increase minus pi by that very small distance, my calculation is going to be 2x equals minus pi. Now it's going to be, I've stored a as a negative number, so if I want to add it, I'm going to have to do minus 0.167. So that's what I'm going to have to type out on my calculator. Minus pi minus alpha, the negative number button to select option A, and then that will give me my next solution. So that will be minus 2.97497. Now actually what I know about this is I'm going to have to half this angle eventually, so I'm going to do it now. So therefore x is equal to, divide it by 2, which will be minus 1.49. The next thing I need to do is work out this next solution, which will be up here. So in this case, I need to move upwards by that value of 0.167. So I'm going to start at pi, and then I'm going to have to, if I want to add 0.167, I need to do it as a double negative, minus 0.167. So on my calculator, I'm going to write pi minus a. So pi minus alpha, negative number button for a, and that will give me, so I'll do that again, pi minus a, and that will give me 3.31. But I know that eventually in this question I'll have to half it, so I'll do that now. So divide by 2, and I get 1.65. And then for the final solution here, 2x equals, I'm going to start at 2 pi and come backwards by that minus 1.67. So that, because it'll be minus, I'm going to add it. So 2 pi, add that minus 1.67 answer. So 2 pi, add a equals 6.12. So therefore my x value I'll need to divide by 2, which will be 3.06. And the only thing I haven't done is I haven't halved my original answer. So x is equal to alpha, so a divided by 2, which is minus 0.084. Minus 0.08 to three significant figures will be 37. So that's the three significant figures, 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 and those are all of my answers to this question. Okay, so let's move on to the next question. So in this question here, I've got quite a difficult angle inside my tan function here, so I'll have to do this in 2 steps. I'll do the 2x first, following BODMAS. So double the 0 to 0, double the 2 pi to 4 pi, and then I'll add pi by 6 so that my angle inside my inequality is the same as the angle inside tan. So I've added pi by 6 to the middle, I'll add pi by 6 to the left, and I'll add pi by 6 to the right, and there I'm going to get, I'm just doing it on the calculator, 25 pi by 6. Now the next thing to do, my preference would probably be to actually turn this into a y. When it actually gets quite fiddly, like this one, my preference is to put the y in there. If it's just a single transformation, my preference is to just leave it as it is. So I'm going to introduce the letter y now. So I'm going to say that tan y is equal to 2. So therefore y is equal to tan inverse of 2, which is tan inverse 2, which is 1.107. I'm going to store that as the answer button just in case I need to recall it later on. So I'll store that now as letter A. Cool. Now the next thing I need to do is work out any second solutions. I'm just going to check whether 1.107 is bigger than or less than pi by 6. So pi by 6 is 0.52, so this is inside the range. So that is going to be a final answer. The next thing I'll need to do then is continue on the pi graph. So continue on the tan graph. So that's pi. That's 2 pi. And then I need to go up to 4 pi, don't I? So that's not pi. This, that's pi. Yes, that is pi. I'll do another one for 3 pi. Dot, dot, dot. Another one at 4 pi. And if I've only added on pi by 6, this distance from here to here is 45 degrees, so I won't have any more of these curvy things. So the next thing I've got then is my output, which was 2. So I'm going to have potentially 5 solutions here, but it's probably more likely only going to be 4. My first solution was 1.107, and each time I go up a solution, I'm just going to be adding pi each time. So I probably won't need that at A value, but y is going to equal 1.107. I'll add on the value pi, so add pi, and I'll get 7 pi by 6. Sorry, no, that's wrong. I'll add pi to this value for A, so A plus pi, 4.25. The next one will be A plus 2 pi, which would be 7.39. That will give us, so that'll be first one, second one, third one. I probably want one more. Add, answer, add pi, 10.53, 10.5 I'll write down. And then I'll just show you that the next one is not a solution. So if I add pi again, I'm going to get to 13.7. And so 13.7 would be my next solution. But 25 pi by 6 is 13.08. So 13.7 would be out of the range. 13.08 is less than it. So the next thing I need to do is with each of these solutions, I need to undo the process that I went through here. I'm going to first need to take away pi by 6 from all of these solutions. Then I'm going to have to half all of these solutions to get me back to my x equals. So at the moment now, I've got 2x plus pi by 6 is equal to all of this stuff here. First thing I should probably do is undo the pi by 6, and I'm going to have to do this very accurately, so I'll have to bring in a again. So the first one is going to be a divided by, a minus pi by 6, which is 0.58. And then I will need to half it eventually, so I might as well do that while the number's on the calculator screen. So that would be 0.291. And that's my answer to 3 significant figures. Now I need to do it with this one here. Well, what was that number? That was a plus pi. So I'll reload my calculator with that value, a plus pi. Then I'll take away pi by 6. And that will give me an answer of 3.73. And then eventually I'll need to half it, so I might as well do that now while that number's on the calculator screen, 1.86. Next number, this number up here was a plus 2 pi's on from there. So I'll reload that on the calculator, a plus 2 pi. Then I need to undo this add pi by 6. I'll take away pi by 6. That will give me 6.87. And then the next thing I'll do is I'll half it, because eventually I want to work out what x is, and I might as well divide it by 2 while 2x is on the screen. 3.43. And the final one will be a, the first solution, add 3 pi, because that was 3 solutions on from a, so it'd be a plus 3 pi, that'd be 10.53, but then I've got to take away pi by 6, so take away pi by 6, that will give me 10.01 rather, but then I need to divide by 2 to get the final answer for x, which will be 5.00. And there we are. All of these x values are our solutions. Here they're all written to 3 figures, and they're all as accurate as we can do them, because we've used the letter A right at this point here when I needed to store this critical value here, because that will then affect every single decimal from there onwards. So these are the most accurate answers you could get, and only these answers will be sufficient as final answers. Okay, so let's move on to the next question. The next question is 2 sine x minus cos x equals 0. Now in this question we're going to be using the identity that tan x is equal to sine x divided by cos x. So to do this, we're at some point going to need to divide by cos x. So the first thing we should probably do is add the cos x onto the other side. So 2 sine x equals cos x. We've added the cos x onto the other side. Now from this line to the next line, we're going to divide by cos. And when we divide sine by cos on the left hand side, that creates a tan. So the 2 will remain there, but then it will be tan x, because we're applying this operation to both sides of an equation basically. So we're dividing both sides by cos. Sine divided by cos will give you the tan. Cos divided by cos will give you 1, because anything divided by itself is 1. Then we'll move the 2 to the other side, so it's going to be tan x equals a half. And now we've got ourselves to an equation that we can solve. The next thing we'll need to do is do tan inverse of a half, and we'll just do that straight away on the calculator. Tan inverse 0.5, and that will give us 0.464. And then we know that on the tan graph, we add pi radians each time to get a new solution. So add pi, and that will give us 3.61. And these are the solutions to the answers. We know that you just add pi or take away pi to get a new solution on the tan graph, so we don't really need to show it at this stage, because we've got a more complicated question where we're probably going to pick up the marks for the rearranging part rather than the finding second solutions part, although that will be awarded some marks. Let's move on to the next question. So again, here we need to create that sine divided by cos equals tan. So this time we need to divide both sides by cos. It's always divide by cos to get tan. It's never sine. It's never divide by sine, it's always a divide by cos. So we're going to divide by cos here. 4 cos x divided by cos x, well that will leave us with the 4, and then 3 sine divided by cos, that would be 3 tan. Next thing we need to do is divide by the 3 to give us 4/3 equals tan. And then we need to do the tan inverse, so x equals tan inverse 4/3, and that will give us tan inverse 4 divided by 3, that will give us 0.927. And you can just see here, if you were to add pi onto this number here, you would get a number bigger than pi, which would be outside of your range. So from this solution to the next solution, I'm going to be subtracting pi. So answer take away pi will give us minus 2.21. And there we are. These are the two solutions to this question. Let's move on to the next one. Now in this one, we're going to need to use sine squared plus cos squared equals 1. So let's write that down. Sine squared x plus cos squared x equals 1. Now what we know is that we can convert any sine squared into a cos squared or a cos squared into a sine squared. This sine though, just bog standard sine, cannot change, but we can always change the quadratic one. So what I'm going to do here is with sine squared plus cos squared equals 1, I'm going to rearrange this into cos squared equals 1 minus sine squared. I'm effectively taking this thing here and taking away sine squared on both sides, so I get this expression here. What I'm then going to do, so this always works. It's always the case that sine squared plus cos squared equals 1. So you can always just pull this out of thin air and use it whenever you think it might be appropriate to use it. It is in this case appropriate to use it. And I'm going to turn cos squared into what cos squared is equal to. And cos squared x is equal to 1 minus sine squared x. So I'm going to be replacing this with 1 minus sine squared x. And then I'm going to keep the 3 sine x where it is, and the minus 3 will stay where that is as well. Then I'm just going to rewrite this a bit more simplified. Now I'm just going to simplify it. It'll be minus sine squared x plus 3 sine x. And then 1 minus 3 is minus 2 equals 0. The next thing I'm going to do with this equation is times everything by minus 1, just because I prefer the quadratic expression to be positive. So it'd be minus 3 sine x plus 2 equals 0. So everything has been multiplied by minus 1. Then what I can do is I can either use the quadratic formula, use the polynomial solver on the calculator, or just do a bit of factorising. Sine x minus 2 and sine x minus 1. So therefore, what we've done here is we've factorised. So either we've got two expressions that multiply to make 0. So either this one makes 0, sine x minus 2 equals 0, or this one equals 0. Because the only way you can multiply two things to make it 0 is if one of those things is 0. So either sine x equals 2, well hold on, that doesn't make any sense because the maximum that sine can be is 1. So this is not correct. There are no solutions following this piece of algebra. No real solutions anyway. And moving on from this one here, we've got sine x equals 1, and the solutions to that are x equals pi by 2. And this is the only solution to when sine x will equal 1, because I remember what the sine graph looks like, and I remember that it reaches the peak of 1 at pi by 2. That's just memorising the graph. So there we are. So whenever you've got an equation, whereby you've got one quadratic term and then one different trigonometric linear term, always change the quadratic one, because it's always the case that sine squared plus cos squared equals 1. You can always rearrange it to get that thing you want to get rid of as the subject, and then you can replace it with whatever that thing is equal to, like 1 minus sine squared, or 1 minus cos squared if it was the other way round. So there we are, that's the answer to this question. This question has an answer of pi by 2. And don't forget that if you've ever got something like sine x equals 2, there are no solutions at that point. Let's move on to the next one. Okay, so this one here has 3 cos squared minus sine squared x equals 2. Now in this question, it doesn't matter which one you replace with the other one. I think I'm going to stick with what we... in fact, I'm going to stick with this minus sine squared. So I know that sine squared x plus cos squared x equals 1. So therefore sine squared is going to be equal to 1 minus cos squared if I move the cos squared onto the other side. So now I'm going to use this up here where the sine squared is. So I'm going to write 3 cos squared x minus, now sine squared is here, and sine squared is equal to 1 minus cos squared, so minus 1 minus cos squared equals 2. The next thing to do will be to expand the brackets here. And we've got a negative at the front of the bracket, so it'll be minus 1, and then it'll be a double negative for the minus and the minus cos squared, so plus cos squared x equals 2. Let's simplify this together. We've now got 4 cos squareds, and then I'm going to take away the, I'm going to leave the minus 1 here, and it will equal 2. Then I'll add 1 onto the other side. That'll give us 3. And then divide by 4. So I've got cos squared x equals 3 over 4. Now the next thing to do would be to square root. So it'd be cos x equals plus or minus the square root of 3 divided by 4. And the square root of 3 divided by 4 is plus or minus root 3. Can't square root 3, but you can square root 4. That would be 2. So now effectively what I've got here is I've got 2 equations for the price of 1. My first equation is cos x equals plus root 3 over 2. My second equation is cos x equals minus root 3 over 2. So the fact that when you square roots you get a plus minus answer still applies to trigonometry. So my first solution for cos here is going to be cos inverse root 3 over 2, and that will give me pi by 6. And then the next solution for this, let's draw out the cos graph in between 0 to 2 pi. For root 3 over 2, it's going to be 2 pi minus answer. So that will be 11 pi by 6. And the solution for this one here, if I type the first one into the calculator, will give me 5 pi by 6. And then the next one, it's still going to be 2 pi minus answer because I'll need to come down to this solution right the way down here. So it's going to be 2 pi minus answer, which will be 7 pi by 6. And there we are, that's the answer to this question. Let's move on to the next one. Okay, so similar for this question here, I can see that in this question I have a sine x and I also have a cos squared. Now in a trigonometric equation you want these two expressions to be the same type of trig function. And the one you always change is the quadratic one. So I'm going to start with my sine squared x plus cos squared x equals 1. That's always true. I can always use that whenever I wish. And I'm going to rearrange it to make cos squared the subject. So cos squared equals, and I'm going to take away sine squared from both sides, 1 minus sine squared x. So now, in the next line of this equation, I'm going to write 3, and then brackets, not cos squared, but what cos squared is equal to, 1 minus sine squared x. And I'm going to open up the bracket on the right hand side, 5 minus 5 sine x. I'm going to open up the bracket on the left hand side, 3 minus 3 sine squared. And then I'm going to move everything onto the right hand side. So 0 equals, I'm leaving behind nothing. I'm going to add 3 sine squared to the right hand side. I'm going to still have minus 5 sine x. And I'm going to take away 3 from the other side, so I'll have 2 left. The next thing to do will be to factorise, so it will be 3 sine x. And then sine x on this side here. And then I need to think how my brackets might work. And I think if I put minus 1 here, and no, if I put minus 2 here, and then minus 1 here, that would be minus 3 sine x, and minus 2 sine x would be minus 5 sine x. Good. So, if I've got two brackets that are multiplying together to make 0, then one of these two brackets will equal 0. So 3 sine x minus 2 will equal 0, that bracket will equal 0, or this bracket will equal 0. So sine x minus 1 will be 0. Well, in this case, in the right hand case, the easier one, sine x will equal 1, and the only way that will happen is when x is equal to pi by 2. Even if when it's from minus pi to pi, the only time that will happen is pi by 2. In this case here, we need to start rearranging it. I'm going to add the 2 to the other side and divide by 3. So I'll have sine x equals 2/3. The next thing I'll do is I will now type this into the calculator. Sine inverse 2/3. And that will give me 0.730. 0.730 because it's 0.7297. The 7 will round the 9 up to a 10, and the 10 will make the 2 a 3, so 7.30. The next thing to do on the sine curve, if it's in between minus pi to pi, will be if I've got a solution at 2/3, it will be this one here, 0.730, or this one over here, so that would be pi minus the first solution, so it would be pi minus answer, which would be 2.41. And there we are, we have these two answers here, and this answer over here. So 3 answers to this trigonometric equation. Okay, so let's have a go at this one now. So first thing I spot is I've got a sine and a tan. Now I think the easiest thing to do here would be to rewrite the tan as sine over cos. And then I'll multiply my fractions together. So it'd be 3 sine squared x over cos x equals 8. Now the next thing I reckon we do is we multiply the cos onto the other side, and then I can turn the sine squared into a cos squared later on. So what I now need to remember is that sine squared plus cos squared equals 1. And then I'm going to take away cos squared from the other side, from both sides. So I've got sine squared is equal to 1 minus cos squared. So I'm going to be replacing sine squared x with 1 minus cos squared. So 3 bracket 1 minus cos squared x equals 8 cos x. The next thing I'll do is I'll open up the brackets on the left hand side. And then I'm going to move everything to the right hand side. So it'd be 3 cos squared x plus 8 cos x minus 3. And then I'll do some factorizing. So it'd be 3 cos x and then cos x. And in this question here, I think the best way of doing this would be to put the plus 3 over here and the minus 1 over here, because then I'll get 9 cos x, and then minus 1 cos x will give me 8 cos x. Lovely. Carrying on down the page if you have room. So now if I've got 2 brackets multiplying together to make 0, one of the brackets will be equal to 0. That's how multiplying by 0 works. So either this thing equals 0 or cos x plus 3 equals 0, which will never be true. There's no solutions here. So I'll just carry on with the other equation. So therefore 3 cos x will equal 1. So therefore cos x will equal 1/3. And the solutions here are going to be cos inverse 1 divided by 3, which will be 1.23. And then the second solution on the cos graph, let's just draw it out, see what happens. We'll have 1/3 over here, cross down, that'll be 1.23 here. So I'll have to come back by 1.23 from 2 pi. So it'll be 2 pi minus answer. And that'll give me 5.05. And there we are, that's the answer to this question. Lovely. Okay, so another one very similar to last time, so it's going to be cos x, and we're going to rewrite the tan as 3 sine x over cos x. Next thing we'll do on both sides is multiply by cos, so on the left hand side it would be cos squared, and on the right hand side it would be 3 sine. And then I'll rewrite cos squared as 1 minus sine squared. Move everything onto the right hand side, so I'll add the sine squared onto the right hand side. And I'll subtract 1 onto the other side as well. Next thing to do will be to solve this. I don't think this is going to be a brackets one, so I think we'll have to use the quadratic formula instead. So grab your polynomial solver, and it's going to give you, well, type it all in. So I'm going to use the quadratic formula, minus 3 plus the square root of 9 minus 4 times 1 times minus 1, all over 2a, that would be over 2, 0.303, or the second solution, which will be minus 3.3. So no solutions with this one here because sine only exists in between 1 to minus 1, so we'll just carry on with this solution here. So let's go back to it, make sure that's our answer button on the calculator, and then do sine inverse answer value. And that's going to be 0.308 to 3 significant figures. And then the other answer on sine will be pi minus answer. Pi minus answer, that would be 2.83. And there we are, that's the answer to these two questions. Right, wow, this one's quite a big question here. So it's 3 sine squared x minus 5 cos x plus 2 cos squared x equals 0. So how do we know which one we need to change? Do we change the cos squared one, or do we change the sine squared one? Well, we've got cos here, so ideally everything in this equation will be in terms of cos. So I'm going to turn the sine squared into 1 minus cos squared. So it's going to be 3 brackets 1 minus cos squared minus 5 cos x plus 2 cos squared x equals 0. Next thing I'll do is I'll open up the brackets on the left hand expression. And we'll now go ahead and simplify. So the cos squareds first, that'll be minus cos squared here, then it'll be 5 cos x, and then it'll be plus 3. The next thing to do will be to times everything by minus 1, so it'll be cos squared x plus 5 cos x minus 3 equals 0. I don't think this one solves by the by factorising, so I'll have to use the quadratic formula. So it's going to be minus 5 plus the square root of 25 minus 4 times 1 times negative 3 over 2 times a, which is 2. So either the first answer is going to be 0.54, or the second solution to the quadratic formula is going to be minus 5.5. There'll be no solutions because cos can never equal an answer outside of minus 1 to 1. So we'll just carry on with this one here. So the next one is going to be cos inverse of 0.54. Just make sure we have that as our answer value. Cos inverse answer will be 0.999. And the second solution here is going to be 2 pi minus the answer, which will be 5.28. And there we are, those are the two answers to this question. Okay, another one here, very similar to the one before. In this question we've got a sine, so we should want everything in terms of sine. So we have to change the cos squared one. So it's going to be 2 sine squared x plus 7 sine x minus 2 lots of 1 minus sine squared x equals 0. Next thing we'll do is we'll open up all of the brackets. That would be minus 2 and then plus 2 sine squared x. Simplify things together, it will be now 4 sine squared x. This one might be a one with brackets. So now let's try and solve with brackets. I think it's going to be the 4 here. If I put the plus 2 over here, then we're going to get 8 sine x minus 1 here. That will give me 7x, 7 sine x, and it will multiply to make minus 2. Lovely. So either we have sine x, either the left-hand bracket's 0, in which case sine x is a quarter, or this bracket here, which will give us no solutions, because sine x will never be minus 2. So x is going to equal sine inverse of 0.25, 0.253, or the second solution, which will be pi minus this, and then it'll be 2.89. So there we are, that's the answer to this question. Okay, let's move on to the next one. Have to be very careful with this one. So the first thing we need to do is we need to turn tan into sine over cos, but only after we've moved it to the other side. So we'll move it to the other side first. So add 2 tan x to the other side, then turn it into sine over cos. Then we'll times both sides by cos to get everything on the same line. And then we'll take away the sine. Now, okay, so here is where some students go wrong. What they then do is, what they do to both sides is they divide by sine. And they think, well, yes, that would simplify things. It would simplify things to 3 cos x equals 2. Voila, and then we can go on and solve the trigonometric equation from there. But one thing about mathematics is that you're never allowed to divide by anything that could potentially be 0 at any point. And sine x has lots of x values when the sine of x could equal 0. So you're not allowed to do this. So I'll have to rub all of this out to what I've done so far, and I'll have to think again about what I could do at this stage here. Now what I should do at this stage here is I should actually move 2 sine x onto the other side. So it'd be 3 sine x cos x, take away 2 sine x equals 0. Then I factorise out sine. Sine, and then in some brackets it will be 3 and cos, and on the right hand expression it would just be minus 2. And then I've got two expressions, this expression and this expression, that multiply together to make 0. So either one of those expressions will equal 0. So sine x could equal 0, in which case the answers are minus pi, 0 and pi. And in this case here, cos x will equal 2/3. if this bracket equals 0. So the solutions that I'm going to get here are cos inverse 2 divided by 3, which would be 0.841. And if my range is in between 0 from minus pi to pi, then my graph is going to look like this, in which case it's just the reflected other part of the graph, so x equals minus 0.841. So I've got these solutions here and these solutions here, 5 solutions in total to this question. Okay, so I've done a question similar to this before in the video, but let's have a go at this one. So the first thing we do here is we divide both sides by 4, and then we square root. So it's going to be cos of x equals the square root of 1 over 4, so that'll be a half. But don't forget that when you square root, you need to do plus or minus. So in this question, you actually get 2 trig equations for the price of 1. You get cos x equals 1/2 and cos x equals minus 1/2. So the solutions for the left-hand expression, we'll write cos inverse 0.5. That will give us pi by 3. And on the cos graph, in between 0 to 2 pi, it will be 2 pi minus this, in which case it would be 5 pi by 3. And on this one here, cos of minus 0.5 will be 2 pi by 3. And similar again, it's going to be 2 pi minus for the cos graph, so that'll be 4 pi by 3. So there we are, we have 4 solutions here to this question. Okay, so let's move on to the next question. In fact, this question is not too bad really, because we've already got both of the trig functions in terms of sine. So we don't need to use sine squared plus cos squared equals 1. We just need to start factorising 2 sine x and 2 sine x. And I think if we put plus 1s in both the brackets, then we've got something that factorises. These two are both the same thing. So effectively what we've got here is 2 sine x plus 1 squared equals 0. Now we could square root here, but the square root of 0 is just 0. So 2 sine x plus 1 is 0. And you don't really need to write plus or minus 0, because 0 is neutral, it's just 0. So in this case here, it's just sine x equals minus 1/2 by the time you've taken away the 1 and divided by the 2. So therefore x is equal to sine inverse minus 0.5, and that will give me minus pi by 6, but that's not going to be one of my final answers because it's not in between 0 to 2 pi. So what do I need to do here? I need to treat the little distance from here to here as a distance of pi by 6, moving backwards. So I'll start from pi and move upwards by pi by 6, or start from 2 pi and move backwards by pi by 6. So my final answers here are going to be pi plus pi by 6, so that'll be 7 pi by 6, or 2 pi minus pi by 6, 11 pi by 6. And there we are, those are the solutions to this question. Okay, so let's move on to the next one. One very similar to the one before. We'll just start by factorising. Don't need to turn the sine into cos or the cos into sine in this one. I reckon it will be plus 3 and minus 1. So therefore we've either got one bracket that equals 0, or the second bracket that equals 0. This will give us no solutions because cos can never equal minus 3. And in this case here, cos x equals 1 will have solutions at 2 points, 0, and at 2 pi. And the reason I know that is just because the graph reaches 1 at the start and at the finish. So there we are, 2 solutions here, 0 and 2 pi. Okay, with this question, we'll have to turn one of the sine squareds into a cos squared or a cos squared into a sine squared. I'm going to change the cos squared one because it's already negative. So it's going to be 3 sine squared x minus bracket 1 minus sine squared. Be careful if you double negative here, so when we expand the brackets, be minus 1 and then plus sine squared equals 0. Tidy things up a bit, it'll be now 4 sine squared x. I'm going to move the 1 onto the other side, so I then get sine squared x equals 1/4. So therefore sine x is either a half or it's minus a half. Because when you square roots, you've got plus or minus. So therefore the solutions here are going to be pi by 6, 5 pi by 6, or the solutions over here are going, oh sorry, that's in the range, so good, that's fine. And this solution here, when I do sine inverse of minus half, I'll get minus pi by 6 and also minus 5 pi by 6 as well. So there we are, these are the 4 solutions to this equation here. Okay, a blast back to the beginning here where we've got an adjustment on the cos, no squareds or anything else, but I'll need to rearrange it a little bit first. So the first thing I'll do is I'll take away that square root of 3 onto the right hand side and divide it by 2. The next thing I need to do is I need to change my angle. I need to add pi by 3 into the center of it, so that's going to give me 7 pi by 3 from pi by 3. The next thing I need to do is I need to then work out what this angle could be, and I'm going to do that by doing inverse cos of that answer there. So inverse cos, fraction button, minus root 3 over 2, and I get there 5 pi by 6. And my second solution to this on the cos graph will be 2 pi minus it, which will be 7 pi by 6. Both of those are still in the range, which is very good. And now the last thing I need to do is I need to take away pi by 3 from each of the angles, so therefore x is going to equal 3 pi by 6, which is pi by 2, and on this one here it's going to be take away pi by 3, so that would be 5 pi by 6. And there we are, these are the 2 solutions for this equation up here. And moving on to the next one, so it's going to be 12 cos x equals 7 tan x. First thing I'll do is I'll turn the tan into sine over cos. I'll times both sides by cos to give me a cos squared up here. The next thing I'll do is I'll replace cos squared with 1 minus sine squared. Open up the brackets, 12 minus 12 sine squared x equals 7 sine x. Then I'll add everything onto the right hand side, so 12 sine squared x. I'm moving it onto the right, so the 7 will still remain 7 sine x, but then take away 12 onto the right, and I will get minus 12. And this one here is a little bit difficult to factorise, so what I'll do straight away is I'll jump straight to the polynomial solver on the calculator, why not, and I'll type it all into the calculator. So I'm going to have minus 7 plus the square root. I'm going to do it by the formula, 49 take away 4 times 12 times minus 12 divided by 2a, that would be 2 times 12, which will give me 3/4. So sine x is either 3/4 or sine x is equal to minus 4 over 3. That can't happen with real numbers because it has a limit of minus 1 to 1, so no solutions here. Otherwise, when I've got sine x, I'll do sine inverse of 3/4. That would be 0.848. And then to get the next sine solution, it would be pi minus this. Pi minus answer. That gives me 2.29. And there we are. Those are our answers to 3 significant figures. And there we are. That's all we're going to go through in this video here. Hopefully you found it helpful. Hopefully you've had a good recap of solving trigonometric equations, and you've seen how we do it in Radians mode. So don't be afraid if your answers are decimal numbers, small decimal numbers, and numbers in between 0 to about 6, because that's 0 to 2 pi, isn't it? So there we are. Make sure you're not solving the equations in degrees and then converting it back into radians. That's just a complete waste of your time. Just make sure you do it just straight in degrees first of all. Lovely. Hopefully you found this video helpful, and thanks very much for watching.